I cannot count how many times I've went out, scanned a project site, extracted the deliverables, whether it be a 3D model, CAD floor plan, or topographic survey from the point cloud, and delivered them to the client, all without the client ever actually seeing the point cloud of their project. It always seems like such a lost opportunity to me that the people spending 10, 20, $100,000 for us to scan a project never actually get to see half of what they're paying for. Sure, we often send them the point cloud in the form of an E57 LAS or RCS, but those usually aren't being opened and viewed by the people that actually hired us. It's certainly not uncommon in my experience that the directors and managers that signed the purchase order don't have the tools or time available to them to open these file formats. So what's the answer here? How can we turn a lost opportunity of being able to wow the individuals we have to thank for the work we've been given? One approach is to upload the point cloud to a web hosting platform, and I explain how to create your own web hosting platform for free in one of my previous videos. Now, this is a viable option, and in my experience, clients really love to be able to navigate through their data set and pull their own measurements and even do simple digitization. But the wow factor isn't really there. There's nothing quite like a beautiful point cloud animation to capture someone's attention, especially when that person is a stakeholder in the project the data represents. If you're in the geospatial industry and work with point clouds, you've probably heard of Nubigon. Just like StarNet is considered the gold standard of least squares survey data adjustment, Nubigon is often considered the gold standard when it comes to point cloud animations. And today, we are going to look at the what, why, and how of animating those beautiful point clouds you spent hundreds of hours capturing and processing to hopefully not only retain your current clients, but to present your data in a manner your competition isn't and start landing new clients. First and foremost, Nubigon is a 3D rendering software for point clouds, meshes, BIM models, and other 3D geospatial data. It allows you to visualize and animate your point clouds and integrate them not only with the data that was extracted from them, but other 3D datasets. For example, you can combine the original point cloud with the 2D CAD plans or the BIM model that was extracted from that point cloud, or 3D models in line work of future construction works. But besides point cloud visualization, there are some very interesting features Nubigon has as well. You can use it to create high-resolution georeferenced orthophotos. You can take 4K screenshots. You can pull measurements and create annotations and keep those in the video animation if desired. You can extract cross-sections of points and bring those into AutoCAD for floor plan digitization. You can hook up a Gamepad controller to your laptop and bring that with you to a conference and let prospective clients fly through datasets themselves. And most importantly, it does all of these tasks easily without crashing, and anyone can learn to use Nubigon extremely quickly, especially after the tips and tricks I go over at the end of today's video in the vast video library of tutorials Nubigon has on YouTube. Why should we bother making video animations of our point clouds? Is it worth the extra time and cost? Is there any real tangible value to these videos? Besides providing those project managers and directors the wow factor of seeing their asset in a way they may have never seen it before, you're also giving them the ability to show off their worksite progress in the fact they are employing new tech. I see it all the time where the clients that are provided these animations usually can't wait to share it internally, which builds your reputation as the service provider within that company, but externally as well. Every day I see various construction, architecture, or civil engineering firms showcasing their recent project with a point cloud or BIM animation, and quite often they're thanking scan company XYZ for the work. It's a great way to allow your client the opportunity to showcase they are utilizing scanning as a means of data capture and market your services for you. To create a video animation in Nubigon, it can essentially be boiled down to a 3-step process. Step 1. import your data. Nubigon accepts several formats of point cloud data such as E57, LAZ or LAS, XYZ, TXT, PTS, and even RCS or RCP. It can also import vector or BIM data in the form of a DWG or DXF and meshes and models as OBJs or GLTFs. Once you select the point cloud you wish to import, Nubigon converts it to an Octree format, which is the secret sauce of how it's able to display massive point clouds in real time without lag. Step 2. Keyframe. There is an object list on the right side of the screen that contains all of your imported objects and cameras, and a timeline along the bottom where you can keyframe your cameras or datasets. To create an animation, highlight a camera in the object list, press the I key to insert a keyframe into the timeline at the playhead location, move the timeline playhead forward. I usually start with 5 or 10 seconds, and adjust the camera angle using the mouse, and press the I key again to insert another keyframe. Holding the Shift key will enable snapping in the timeline. Repeat this process as desired, and when you're finished adding in keyframes for your camera's views, adjust the timeline bounds. You can preview the animation by moving your playhead to the start of the timeline and pressing the spacebar. If you're unfamiliar with the concept of keyframing, it's really quite simple. You set the position and orientation of an object where you want it at a moment in time, in this case the camera, lock it in using a keyframe in the timeline, then move the object to a new position and orientation at a new point in the timeline by inserting a keyframe some amount of time forward in that timeline. The object you are keyframing will move from the initial position to the new position at a speed dictated by the separation in time of the keyframes. So if the camera is pointed at, say, the front door of a house at the 5-second mark in the timeline, then at the 15-second mark it moves to look at the corner of the house, it will animate the camera from being in front of and looking at the door to being in front of and looking at the corner of the house in that 10-second span. Nubigon uses keyframing to animate not only the camera, but also any other object in the object list. We will look at this a bit more in just a minute. Step 3. Export. Once you're satisfied with the animation, you can render the video by moving the playhead back to the start of the timeline and pressing the export button. You can adjust the settings here to suit your desired application. I will go into depth on these more near the end of the video. Click the render button and choose your output file location. Nubigon will render your clip in a few minutes depending on your settings and the length of your clip. And that's it, you're done. There really isn't any reason someone can't create a simple point cloud animation in well under 10 minutes of input time. Step 4. Compiling clips. This is optional. If we want to spend a bit more time and make something a bit more interesting, we can export numerous clips, each using a different camera movement visualization style, showing different objects, and compile them together in a video editing software. My recommendation for that will be DaVinci Resolve. It has a free option that is remarkably powerful and easy to use considering it doesn't cost a thing. When taking this route, I have a list of predefined camera movements I'll run through that I'll share later, and typically create a number of clips for each camera movement using different visualization styles such as X-ray if I want to cut through part of the point cloud to reveal features through walls or roofs, or I'll use clay rendering if I want to highlight fine details, or keyframe objects if I want to show how different BIM or CAD elements interact with each other, which leads me to my next topic. One of my favorite features in Nubigon is its ability to easily combine point cloud and CAD elements. If you have CAD line work or models were extracted from that point cloud and still contain georeferencing information, they will automatically fall into place. But even if they aren't, it's extremely easy to align them manually. Previously, we looked at adding keyframes to the camera, but like previously mentioned, any and every element in the object list can be independently animated using keyframes. There really is no limit to the extent of creativity that can be accomplished using keyframing in Nubigon, and some of the examples I've seen online are nothing short of digital works of art. Nubigon's plane tool not only creates a whole new dynamic when keyframed into an animation by revealing new elements of the point cloud, but it also serves another very interesting purpose when it's combined with Nubigon's orthophoto tool. Cutting a plane helps to remove overhead obstructions when you create a georeference TIFF file with that orthophoto tool, and that orthophoto you made can be imported into AutoCAD for digitization. This export is not unlike an orthophoto you would get from drone photogrammetry that you would trace over to digitize roads, driveways, buildings, or other linear features. The big difference here is that you get an orthophoto that is capable of being much more accurate because it was created with terrestrial scan data, which is generally far superior in terms of accuracy when compared to UAV photogrammetry data. You can also use the orthophoto tool without cutting a plane or cross-section using the X-ray visualization style. A quick tip, changing the pixel size will greatly increase the resolution of the image, but it will also increase the file size. This orthophoto was created with a 1mm pixel size that gave me a 1.2 gigabyte orthophoto for some context. Also, if you see any gaps in your data that you want to minimize, simply highlight the point cloud in the object list and make that point size larger. What I think is a really cool feature is if instead you would like actual points you can snap to in AutoCAD, once the plane is created, you can make a section, select it in the object list and go to File, Export CAD, and it will create a DWG that contains actual AutoCAD points in the same coordinate system of that point cloud. An example of how you could use this is if you need to create floor plans and elevation views of a building, instead of trying to deal with bringing in a point cloud into AutoCAD, which can be a little clunky, slow, and you have to deal with recap, you can export a section of each floor and wall as a separate DWG or TIFF, depending how you prefer to digitize using points or an image, and distribute those to your feature extraction team. Another quick tip, when exporting your orthophoto or section, there is a drop-down in Nubigon labeled Offset. Make sure it matches the point cloud you're extracting. This will make sure the TIFF or DWG retains that georeferencing information of the source point cloud. Although since Nubigon works natively in meters, the exports will be in meters. This isn't really a big deal if you're working in a different unit, as you can copy and paste the points into your working drawing, group them, then scale them about 0, if you're working in feet, inches, or what have you. Same with the orthophoto. I use the command map insert, making sure my drawing units are set to unitless, and the ortho will need to be scaled into place using the same method. This next feature I actually didn't know about until recently, and I think it doesn't get talked about enough. Nubigon has several different options when it comes to navigating your datasets. The default is orbit mode, which is pretty standard for most 3D oriented software packages. But when the fly mode is combined with any gamepad that can be used with a PC, this one cost me $14 off Amazon, this allows you to navigate the point cloud in a manner I've personally never experienced before. You may be thinking, why would I want to do that when I can just use a mouse? If you've ever been to a geospatial conference, you start to see a pattern of what captures people's attention at a booth. It isn't having your $150,000 scanner displayed out front or giving away a bunch of knickknacks. If you can gamify your services in some way, you'll probably be that one booth that has consistent traffic all day of people wanting to see what the fuss is about. The gamepad option allows you to set up a big screen TV connected to a laptop and immerse your prospective clients in the dataset you've captured. They can get a close-up look of the data and really see what your company is capable of, all while capturing their attention just enough to keep them there, but you can still have a conversation with them and explain the services you provide and how your team was able to capture this particular data set. I've seen the VR headset option before and it can be nice, but it definitely has its drawbacks. Maybe it's just me, but when I get a really nice data set in Nubigon for the first time, connect it to a big screen and hook up the controller, it's a total time warp. 10 minutes go by like that. If your company promotes at conventions, just this one feature is well worth the cost of Nubigon, considering what an average booth rental goes for these days, and the increase in traffic your booth is likely to get using this tool. So why am I bringing up Nubigon now? It's been around for years. Well, just a couple months ago, Nubigon went through a fairly substantial update where they released version 7.0. They added physically based rendering or PBR for point clouds to simulate realistic materials, which has been around for meshes and models for some time. But as far as I know, Nubigon is the first piece of software to do this for point clouds. And the results are very interesting. The clay rendering preset really brings out the details in those high resolution datasets, especially when paired with the new ambient occlusion that simulates soft shadows. And being able to adjust the metallic visual settings really makes those industrial scans stand out. They added image-based lighting for realistic reflections, transparency for meshes, which is handy for windows, or if you want to make viewing through doors easier, additional settings for creating 4K screenshots, sRGB color space for more balanced colors, and quite a few other features as well. Version 7 was a big jump in its visualization capabilities, and in my opinion, Nubigon went from the leader in the industry in terms of point cloud visualization tool to the other guys better do something fast if they want to remain competitive. Nubigon obviously isn't the only software provider that animates and renders point cloud data. Cloud Compare has an animation plugin, Reality Capture, Arena 4D, Octree, Blender. There are a bunch of other pieces of software that dabble in the rendering of point cloud animations. So why Nubigon? Why is it the most popular point cloud animation software out there in the geospatial industry? Because while other pieces of software may throw in an animation feature as an afterthought, Nubigon has made it their first, second, third, and fourth priority. The riches are in the niches. They focused on one thing and knocked it out of the park. I've tried several other software packages and I'm usually pulling my hair out at the end of creating an animation. The learning curve with Nubigon is almost non-existent, and hands down, my favorite thing they did as a company, tutorial videos on YouTube. It's 2025. If you're a software provider and don't have tutorial videos on YouTube or on your website that are easily accessible, what are you doing? You're not servicing your customers as good as you can be. I cannot count how many hours I've wasted dealing with customer support or digging through 600-page manuals for other software packages trying to figure out how to do something that could have been answered in a 2-minute video clip. Nubigon has a huge library of effective, concise how-to videos, and in my opinion, it really cannot be understated how important this is. If I'm spending money for software these days and there's little video support online, that's a huge mark against them when it comes to me voting with my dollars. Blockbuster is dead, MySpace is gone, we're not in 2003 anymore. To all the software providers with slow customer support and non-existent video tutorial libraries, it might be time to reevaluate your training program. Companies like Nubigon, StarNet, Enforce that have taken the time to do this as a customer, it makes the world of difference. The million-dollar question, Nubigon isn't free, so is it worth it? Let's take a look at their pricing structure on their website. It's $75 a month when billed annually, or $3,500 for a perpetual license that includes free updates and no maintenance fees. And it actually looks like they're running a sale for the rest of the month, so you can get that perpetual license for closer to $2,500 if you hurry. Now that's not cheap when I can make an animation for free in Cloud Compare or Blender. And if I did this as a hobby, those Cloud Compare animations would probably be good enough. But when we're talking about marketing a legitimate business, it's really not that much to spend on something that will arguably give you the best video representations of your point cloud possible, give you a huge opportunity to draw in customers at expos, and with the tools it has to help digitize 2D floor plans, I don't think that price is too bad at all. The first step of importing the point cloud can take some time depending on file size of the point cloud and the specs of the hardware being used. I use a dedicated processing computer, so it doesn't really affect me too much, as I can let the import process run in the background or go overnight, and when I come back, it's ready to go. But if you only have one computer and are in a rush to get on with other tasks, it is something to plan ahead for. You can also decimate or segment the cloud into multiple parts prior to importing to reduce the file size and therefore time to import. The import step is a one-time process, and once the point cloud is converted to an Octree, the next time you simply open the Octree file and it will load instantaneously. For every animation I do, I reference a checklist I made that has a lot of the different camera movements that seem to work well for me. Most of these are commonplace with conventional and FPV drone videography. Let's run through them now. There's the push in or pull away. Here I'm moving the camera towards or away the point of interest, either with the camera angle holding steady or tracking a particular object. The pan, very similar to the push in, except the camera is moving perpendicular to the line of sight with the camera angle fixed. The orbit, a classic and fairly self-explanatory. I really like this camera movement when viewing the entire point cloud from afar as an establishing shot. The reveal. This one can be accomplished in a few ways. One way is to start with the view being obstructed by a close object, then reframe the camera to reveal the rest of the data set. Another combines it with a push-in where the camera is moving forward and pointed down to start, then pans up to reveal the rest of the data set. The crane. This involves moving the camera up while maintaining lock on the point of interest. You can also try leaving the camera angle fixed for a slightly different feel. The bird's eye view. Here you maintain a nadir camera angle while moving the camera horizontally. You can add a twist by adding in a camera rotation while it's moving as well, or you can omit the horizontal movement altogether and just have the camera rotating in place as the primary camera movement. The turntable. Nubigon has a very slick workflow for creating this animation, and it can be effective at giving a 360-degree view of a dataset or particular focal point you want to highlight. The dive. Here you're starting out from overhead and dive into the object of interest. This gives the viewer an overall picture of the dataset, but also ends the shot with a close-up to view finer details. The walkthrough, another classic for point cloud animations. Here you're mimicking the view of a person walking or flying through the dataset. The fly mode is very effective for fine-tuning camera position for these shots. Besides mixing up camera movements, I also like to try different point cloud visualization styles. I find X-ray works especially good when combined with CAD or BIM elements. I usually use both the standard version of X-ray and the inverted and splice between them in post. And sometimes X-raying the elevation visualization style can add some nice variety as well. X-ray does a fantastic job of hiding artifacts and point clouds with fuzz in them. If I want to make an animation of a dataset where there is some noise on the data I want to hide, I know I can rely on the X-ray feature to put lipstick on a pig, so to say. And if you have a mesh or point cloud with a lot of detail, clay rendering and ambient occlusion are your friend. If you have a point cloud with metal features, such as an industrial scan, you can try turning on PBR and increasing the metallic settings and decreasing the roughness to really make your dataset look like it was actually created from metal. A technique I've found visually appealing is adding pauses or breaks between camera positions to allow the viewer time to take in everything they're seeing. You can jump from point A to B to C, but spending a few seconds sitting static at A, at B, at C adds a nice touch, especially if you integrate these pauses with some movement from other objects in the scene. For the most part, the export settings are fairly straightforward. I usually opt for a 4K export in terms of resolution. It creates a larger file size but a better product. The no tiling option is supposed to eliminate the tiling effect by rendering a subsampled point cloud. I haven't tested this extensively, but have found in every case that I have tried, it did more harm than good. If you are experiencing tiling in an animation, it may be worth giving it a try though. Super sampling is supposed to enhance the quality by rendering at a higher resolution and then downscaling that, minimizing aliasing and improving details. I often have a hard time seeing any obvious difference between the two. Point count controls the GPU memory used, thus determines the maximum number of points that can be rendered at any one time. I use as high of a setting as the computer I'm using will allow me to do. Since my laptop has 32 gigs of RAM, I can max this setting out at 24 gigs. Video bitrate is the amount of data encoded in a video per unit of time, typically measured in megabytes per second. A higher bitrate allows more data to be encoded per second, resulting in better quality video but larger file sizes. As you adjust the export resolution, the bitrate automatically changes, but sometimes it may need further customization. For example, both of these clips were exported in 4K, but the one on the left has a bitrate of 80 megabytes per second, whereas the one on the right has a bitrate of 240 megabytes per second. There is some very obvious artifacting in the 80 megabytes per second version that is removed by increasing the bitrate. So why don't we always just max out the bitrate if it will give us a better quality video? Mostly because of file size. The 80 megabyte per second version was 336 megabytes, whereas the 240 version was 1.14 gigs. I usually save adjusting this parameter until I see artifacting starting to creep into an animation. If I have the opportunity, I really like to merge real-world drone or handheld video with a point cloud animation of that object. This is fairly easy to accomplish by having some video footage you shot of the subject on one screen and using Nubigon on another screen to match the drone shot as close as possible. Then in post, I overlay the clips, give one some transparency, and adjust their position to line up as best as possible, and either use a cross dissolve or fade to transition back and forth between the two. This one should be a no-brainer. Add some soft, subtle music behind your animations. It makes a huge difference. Just be careful to keep the audio levels reasonable. In this video, we focused on Nubigon, but a lot of the tips, tricks, and really the essence of the video can be applied to whatever animation software you have available to you. Just because you don't have Nubigon, it doesn't mean you can't make a point cloud animation. And I get it, Nubigon isn't cheap. Not everyone can afford the extra expense if you're starting out. But if you're regularly making point clouds, I do think it can pay for itself, and using it does bring the potential of enticing new clients and helping growth quite a bit. The orthophoto and section tools are really handy as well, and if you don't have any other point cloud extraction tools besides CAD, these could really fill a void. Now, since I have Enforce, am I going to use Nubigon instead to cut cross sections? Probably not, but similarly, Enforce also has a point cloud animation tool, and would I use that instead of Nubigon? Probably not. Each does what they're designed to do very well, and just like a carpenter doesn't try to use a ball peen hammer to drive nails, we surveyors can benefit greatly from having the right tool for the right job. That about wraps it up. The next video I'll be releasing that I'm currently working on is trying to answer the question of whether or not it's feasible and makes sense to perform a tree survey with laser scanning. So far, after working through a few hiccups, the initial results are quite promising and could very well have a real impact on the way we look at those often long and boring tree surveys. Until then, thank you all for watching. Subscribe if you want, like if you feel it's warranted, and I'll see you next time.